So today we're going to be looking at section 2 of chapter 1. First section we are not covering. So today we're talking about points, lines, and planes. Lesson objective is for you to understand basic terms and postulates of geometry. So we have 10 vocabulary terms. Earlier in the week we matched those definitions up with those terms. So that's what you're seeing up here in front. We're just going to talk about some things. I'm going to mark some things, point out some things that you need to focus on.
When you did the Spanish, was it just general 6 plus?
No, this is Spanish.
Is it Nebraska?
It's still the.
I was to the bottom of all the Spanish ones.
There was a Spanish.
I went on math 6 plus, but not a Nebraska math 6 plus. It's called general 6 plus.
For Spanish, whatever it was
Okay,
for Spanish.
because if you keep going below it's growth, they're no longer test.
Okay.
I just.
So, when we talk about a point names a location and has no size. Okay? If it has no size, okay, we're not going to be able to see it. We have to have something to represent that point. So that's where we use that dot to show that point. Thing that we're going to really stress today is how we name these different pieces. So a point is named using only one capital letter. So when I see the diagram, the dot with the capital letter A, if I was asked to name the point, I would just use that capital letter A. Okay, I don't have to put the word point with it, it's just that one capital letter. If we move to line, we talked about a line being a straight path. Again, it has no thickness because a line just means we've taken all these points, okay, and they're just really close together and they form that line. So it has no thickness, but again, we have to have something to represent a line, so we're going to draw that. It extends forever in both directions. So that's why we are seeing the arrowheads on each end. When we name a line, we have several different options. One of them is to use the line symbol, which is a bar with arrows on both ends. When we do that, we have to name 2 points that the line goes through. So we only have 2 points showing. We have point A and we have point B. Order does not matter. So I could name this line AB, or I could name it line BA. Again, order does not matter. Another way that I can name a line is sometimes you will see a lowercase letter. It's not with a point. Okay? That lowercase letter is all by itself. If we have a lowercase letter, we can use the word line and then that lowercase letter. Okay, so then we actually have to use the word line with the letter M. So different ways that we can name that line. Plane. A plane is a flat surface that extends forever in all directions, but we're just talking 2 dimensions. So again, because it keeps going on forever, we have to have some sort of boundaries. So most of the time, a plane is going to be represented with some sort of a quadrilateral rectangle. This one looks slanted, it's a parallelogram. Okay? But here we see 2 different planes, okay, that are actually 3-dimensional then, but we're seeing it in 2 dimensions. So we have to really be careful with that. When we name a plane, we have to use at least, okay, a minimum, so at least 3 non-collinear points. So I can choose any 3 points that are not on the same line. So you notice that this piece that looks like it's going straight up and down is shaded a little bit. Okay. On that plane, there are 1, 2, 3, 4, 5, 6. There are 6 different points that are labeled on that plane. Okay? There's a lot of others that we just don't see because they're not labeled. But there are 6 points on that plane that are labeled. If I want to name that plane, I have to use at least 3, okay, that are not in a straight line. So they used the letters E, F, and G. Okay, those 3 points are not on the same line, so they're non-collinear. Okay? But if I only named those 3 points, some people think it's confusing to think of that entire plane. Okay? Most of the time, if we're looking at a quadrilateral for the plane, it makes more sense to me if you would use 4 points and you would use those 4 corners. Okay? So that's another way that you can name it, but you can use any 3 or more. If you wanted to, you could use all 6 of those points. Okay? If you use more than 3, you can start on any point you want. Okay? You can go clockwise or counterclockwise, and then you just follow them in order. Okay? What you don't do is jump all over the place. Next word is collinear. Okay? We said collinear points are points that can be connected on the same line. Okay? If we only have 2 points, any 2 points are always going to be collinear. If I have 2 dots, I can always make a line through those 2 dots. Okay? So in this example here, those 3 points, A, B, and C, are collinear. Non-collinear, then, we said, are 3 or more points that cannot be connected on the same line. Again, it has to be 3 or more, because if we only have 2 points, 2 points are always collinear. So if there's 3 or more that cannot be on the same line, they're called non-collinear. Coplanar. Again, this is where we need to think a little bit more because we've got a 3-dimensional picture in 2 dimensions. Okay? Some people are able to do that in their head very easily. Other people, it takes some practice. Okay? A couple things that are helpful is, again, marking on that picture, whether you're just darkening things or using colored pencils, using highlighters, whatever helps you, okay, to help visualize that information. So it says 2 or more objects that share the same plane, so the same flat surface, are coplanar. So here they are talking about points P, Q, R, and N. And they are telling me that those 4 points are coplanar. Okay? If I look at the flat surface that those 4 points are on, that flat surface is this pentagon that I see. But we also have to remember in real life that shape, that plane doesn't have those boundaries. Okay? It keeps going forever and ever. We just see boundaries because we have to be able to visualize something. So we need to have those boundaries. Okay? So those 4 points, we could even include the point O, and they'd still all be on the same plane, that same flat surface, that pentagon shape. Non-coplanar, 2 or more objects that are not in the same plane. So this time we're working at point R, T, Q, W, and V. Okay. When I'm looking at all 5 of them, they are non-coplanar. They are not all 5 on the same flat surface. Okay. I could take a smaller amount of them and find some that are coplanar, but not all 5 of them are in the same plane, in that same flat surface. A segment. A segment is part of a line. So I see a segment up here on the diagram, but I need to remember it's just part of a line. We can keep going both directions. We're just talking about part of it, just that black part. So it has 2 endpoints, A and B, and then all of the points in between it. So when we name a segment, we just use the bar. We do not have the arrows going in both directions like we did for the line. Again, the 2 endpoints, order does not matter, either AB or BA. Most of the time, your printed materials are going to go alphabetic. Okay? But again, order does not matter. This means the exact same thing. Key thing is that symbol. And if we're talking about a segment, it's just the bar. The line, we know, is going both directions. Thanks. Array. Array, again, is part of a line, so that could still extend in the other direction. It's part of the line that starts at an endpoint and extends forever in one direction. Important piece here is that the name always starts with the end point. Okay? And the end point is point D. Okay? That's where the end point is. So it starts at D, and then we have to use a second letter again. Any letter, any point that ray goes through. So we have several options. We've got the ray symbol, which is just an arrow going to the right. So it's starting at D, and then we can use point A, or we could use point B, or we could use point C. It does not matter because the arrow says we're going through that point and we keep going in that one direction forever. But again, we always start with the end point. And if we always start with the end point first, the D, then our arrow is always going to go to the right. Okay? In the past, I have had some students that want to name it kind of how it looks. Okay, so they might want to name this DB and name it that way. Okay. We always need to start with the end point. Okay, so we want the D first, then the other point, which means your arrow's always going to the right. Opposite rays. Opposite rays are two rays that have a common endpoint and form a line. So when we look here, if we didn't have anything else, we just had this picture, most people would say, well, we have a line. Okay? We do, but we also have opposite rays. And because we're naming rays again, we need to start with that common endpoint. So when I look for rays, I have a ray that starts at B and goes through A. I also have a ray that starts at B and goes through C. So those are my two opposite rays. They share the same endpoint, which is B. They just go in opposite directions, forming that straight line. But again, when I name it, the B is always first.
So, I'm so confused about the arrows. It always has to be right?
Right. The arrow is always going to point to the right because that end point is always going first. Okay? When I look at this ray BA, okay, it just tells me that the ray is starting at point B and it's going through A.
So you can't do A, B, and they're going that way.
Correct. You cannot do it that way. Okay? So when we name it, we're just giving it a name. We're not saying which direction it's going. If it's going left or right or up or down or whatever direction. Okay? We're just naming the ray. And then next to it, we have a page that has some postulates. Postulates are just kind of rules, statements that we just have to take that they are true statements, things that we can use. Some of these things we've already kind of talked about because they're kind of built into those definitions. So this first one says, through any 2 points there, and then it gives us a blank. We need to fill in some words there. If you look at this diagram, through any 2 points, what do we see through those 2 points?
Line T.
Okay, we see a line. So through any 2 points there is exactly one line. Through any 2 points, there is exactly one line. The second one, if something intersect, then they intersect in exactly another blank. So what do we see intersecting in our diagram? Jean?
Lines.
Okay, we see lines. So if two distinct lines intersect, then they intersect in exactly where are those two lines intersecting?
1 point.
Okay, they're intersecting in this diagram at point E, so intersect in exactly 1 point. This postulate started out with the word if. Okay? If the lines intersect, they intersect only one place. It doesn't say that all lines intersect. If the lines are not intersecting, what are they called?
I know. I know when we
Starts with a P.
parallel.
There you go, parallel. Okay?
I'm so confused.
Okay, what's your question?
It's intersect in the exactly one point.
Right. If two lines intersect or cross, there's only one place that they can cross.
Yeah, like where they intersect.
Right.
That's like,
They can only do that in one place. Okay? So if they intersect here, when we keep going, they're never going to touch again somewhere else. They can only cross one time. This next one, okay, so here again, we've got planes that are intersecting. So actually 3 dimensions, but we only have 2 dimensions. So this one's a little bit trickier. It says if 2 distinct planes intersect. So we have this one that's kind of going sideways. We have this one that's going up and down. Okay, so they're intersecting. What do you think their intersection is? Where are those 2 pieces actually touching or intersecting? Anyone have an idea? What do you think, Jean?
where the line is.
Okay, very good. They intersect at this line. So they intersect in exactly one line. What I have found that is helpful for lots of people when we think about intersecting planes, okay, is if you think about the classroom, okay, we have big flat surfaces. We've got the 4 walls, we've got a ceiling, we've got a floor. So if I have the front wall and the ceiling, they are intersecting. They are touching all the way across, which makes that line. Okay? Even though we see boundaries here, that ceiling continues on to the other classrooms. Okay? The wall continues up. Okay? We just don't see it. We see boundaries, okay, but they actually continue up. So sometimes finding something like that is helpful to help visualize. And then our last postulate says, through any 3 non-collinear points, there is exactly one, what do we see here? Plane. So if we have 3 points that are not on the same line, they are going to be on exactly one plane. Okay, I can take 3. I could take 3 pieces of wood. Okay, they could be different lengths. Okay, doesn't matter, or they could be all the same. But I could take a flat surface, okay, maybe a big sheet of plywood, and I could lay that plywood, and it would touch all 3 pieces, even if they were all different sizes. Okay, and that's why you can build a stool with just 3 legs. That's why a tricycle will stand up by itself, will not tip over. Okay, it will stand by itself because it has those 3 points of contact to whatever it's on. Okay, a bicycle, only 2 won't. Okay, it won't stand up unless you put the kickstand down, which then gives it that 3rd piece of contact. So there are 3 points touching the flat surface, the sidewalk or driveway or whatever you might be on. Okay. So sometimes too, I'll try to throw out those things where you can think of different objects and just instead of just thinking points. So that is it for this section. Again, lots of information. Really need to focus on those little details, okay? Because commas or no commas makes a difference. The symbols with the letters make a difference in what it means. So detail is very important.